Normally when we do a question like this, which requires us to solve for x and y, and we're given two equations, we're used to using simultaneous equations to solve. But in this case, we are going to use a matrix method to solve for x and y. Firstly, if we arrange the equations underneath each other, we can then see how we can form matrices with both of these equations. These matrices are going to be in the form of AX equals B. And the A is simply the coefficients of X and Y. X is simply X and Y, and our B are our constants on the right hand side of the equal sign. And if you wanted to check at all, multiplying these two matrices out will actually give you these two equations. So if we do a quick check, 3 times x is 3x, going this way now, times, negative 1 times y, which is minus y, and that is equal to 16. Then you've got 2 times x, which is 2x, plus 5 times y, which is plus 5y, and that is equal to 5. So very simply, all we need to do here is solve this equation. And we can do that, if you remember, when we are presented with ax plus b, we have to pre-multiply the ax by the inverse. So we are pre-multiplying ax, so that means we also have to pre-multiply on the right hand side as well. Pre-multiplication of a, pre-multiplication of a, or a inverse rather. So that means we will be left over with x equals the inverse of a times b, or in other words, just x, because the identity times x is just x. Okay, so a few things that we need to find is we need to go ahead and find the inverse of a. So if we go ahead and find the inverse of a, this is going to be 1 over the determinant, which is 3 times 5, which is 15, minus negative 1 times 2. And on our matrix side, we swap the a and the d, which is 5 and 3, and make we make b negative and c negative as well. Okay, so finally we have 1 over 17, 5, 1, negative 2, 3. Okay, so we've got our inverse of a. Now we can get back to the original equation of x equals a inverse b. We take a inverse, and multiply it by b, which is 16 and 5. Okay, so if we go ahead and do this matrix multiplication here, we have 5 times 16 plus 1 times 5. This gives me a total of 85. And negative 2 times 16 plus 3 times 5. This gives me negative 17. Scalar out the front is 1 over 17. And at this stage you may ask, do we leave the fraction out the front? We can leave the fraction out the front, but we want to find our x and y values here. So if we go ahead and multiply this fraction, we'll get a exact x and an exact y value for this unknown matrix, which is this and this here. And if you do that, 85 times 1/17 is 5, and 1/17 times -17 is -1, which gives us our x and y value, and we've done this using matrix methods.